Hello and welcome. My name is Sunshine, the project manager, Sunshine Resources. In this video, we shall be learning how to make liquid soap, either for domestic use or for commercial purposes. But before we go into the production proper, let's go through some precautions you need to take as you do this production. Because the chemicals we're dealing with here are industrial chemicals, hence you need to take precautions. So let's go through the precautions. Do not make the preparation near naked flames or fire. Avoid direct contact of soap chemicals with the skin or eyes. Keep all soap chemicals out of reach of children and do not taste any soap chemicals. Please make sure you keep to these instructions because these chemicals can be hazardous to the skin or eyes if not properly handled. We will now go through the list of chemicals in order in which we dissolve them in water. The first one is called nitrosol or antisol. You can either use nitrosol or antisol. Nitrosol dissolves instantly in water, while antisol takes time to dissolve. Both chemicals have appearance like powdered milk. The second chemical that will go into the solution of nitrosol or antisol is called caustic soda. Caustic soda consists of crystalline structure like that of sugar. And the third chemical that will go into the solution is called soda ash. Soda ash has a very coarse crystals and a dirty white color. Now the fourth chemical, which consists of four chemicals, are as follows. The first one is sodium lauryl sulfate, also called SLS. In place of sodium lauryl sulfate, SLS, you can use Texapon. You can either use Texapon or SLS. Either of them will be okay. People are fond of using the two of them at the same time. That is not correct. You can either use sodium lauryl sulfate or Texapon. Any of them will be okay. Sodium lauryl sulfate SLS has rice-like appearance, while Texapon has jelly-like appearance. The next chemical in this category is STPP. STPP, which is also called sodium tripolyphosphate, looking so much like table salt. Sulfonic, which is the next chemical in this category, is a very thick, dark chemical like honey. And the last one here is foaming booster, a transparent chemicals which help to boost the foams of soap. In the group 4 category, order is not important. You can start with anyone and end with anyone. But there's one more point I want to make very clear here. Sulfonic is not the same thing as sulfuric acid. Sulfonic has honey-like appearance, while sulfuric acid is a transparent, odorless liquid, very dangerous if concentrated. Make sure you get sulfonic and not sulfuric acid. The fifth chemical is the color and the sixth chemical is the perfume. Well, there are different kind of perfume and color in the market. You can make your choice. Please note that you will have to dissolve these chemicals in this order that I have listed. If you miss the order, you will not get a good quality soap. Hence, it has to be in this particular order: nitrosol or antisol. That's number 1. Number 2 is caustic soda. Number 3 is soda ash. And the fourth group of chemical, which I said in this category, order is not necessary. You can start with anyone and end with anyone, are SLS or Texapon, STPP, sulfonic, and foaming booster. And the fifth chemical is color, while the sixth one is perfume. Now let's see the quantity of materials required to produce 20 liters of liquid soap. Nitrosol 130 gram, and if you are using antisol, you also use 130 gram. Nitrosol or antisol 130 gram. Caustic soda 100 gram. Soda ash 350 gram. SLS 100 gram. And if you are using Texapon, you use 200 gram. STPP 150 gram. Sulfonic half a liter. Foaming booster half a liter. Color 50 gram. And perfume 40 ml. Alright, now we are into the mixing of the soap chemicals. The total quantity or volume of soap we're going to produce here is 20 liters. As you can see, what we're doing now, we have just measured the volume of water, some volume of water into the empty bucket, and now we are adding nitrosol. I told you can use nitrosol or antisol. Any of them will be okay. Nitrosol dissolves instantly in water, while antisol takes time to dissolve. Nitrosol is also called instant production, so any of them will serve. Most of the time when you use antisol, you will have to wait, you have to do the preparation and keep it probably overnight for the lumps to dissolve before you can start using. So now we've just added nitrosol and we are stirring it now. Make sure you stir it properly so that you can have a uniform solution, so that reaction can take place in all parts of the solution. The next thing we're going to add to it is caustic soda. Caustic soda is what we are dissolving in water now. Now notice how we are doing it. We will first dissolve the caustic soda in a solution of water. We are not going to dissolve it directly into the nitrosol solution, because if you do that, it will form lumps. We first dissolve it in water in another bowl before we transfer the solution into the nitrosol. This is caustic soda. Now we are stirring a very strange chemical. Whenever you dissolve caustic soda in water, the container feels hot. This is because the reaction is an exothermic reaction. Caustic soda in solution liberates heat to the environment, and that's why the container feels heat. It's an exothermic reaction. So now we are dissolving caustic soda in water, then later on we add it to the nitrosol solution. Stir it properly to ensure that everything is dissolved. Now we are going to add it to the solution. I want you to notice what happens when you add the caustic soda solution to the nitrosol solution. You will notice that the total mixture will coagulate, similar to what happens when you are preparing your fresh pap. When you are adding hot water to a fresh pap, the solution will now thicken up and coagulate. Let me show it very well. You can see that the solution is very thick. This is what caustic soda does to nitrosol. Nitrosol is a polymer. That's why it behaves like that. It's a carbohydrate. Stir it properly to make sure that you have a uniform solution. The next chemical we're going to add to it now is soda ash, which is the third chemical. This is the third chemical. Soda ash is what we're going to dissolve in water now. Soda ash is about the largest material that we're using in this production. It's about 350 grams. So just like I said earlier, first dissolve it in water in another solution, and then you make sure the particles are properly dissolved before you transfer the solution into the already made soap solution. This is to avoid formation of lumps in your soap. You have to ensure that all the particles are properly dissolved before you transfer the solution to the final soap solution to avoid formation of lumps. As you add the soda ash solution to the soap solution, it's going to neutralize it, but don't worry, the solution might turn watery, but with the addition of other materials, it's going to thicken up later. So make sure you stir it properly so that you have a homogeneous mixture. So just like I said, this is the third chemical we're adding to the solution, soda ash, and we're stirring it now so that we have a uniform and homogeneous solution. So now we are moving into the group 4 chemicals. Here order is not important. You can start with any one you want. You can start with SLS, you can start with STPP, you can start with sulfonic, anyone. But here we are starting with SLS. This is sodium lauryl sulfate. So we dissolve it in water now. We're stirring it so that the particles will dissolve before we transfer the solution to the soap solution. This is sodium lauryl sulfate, SLS. Here we're not using Texapon, we are using SLS. We have to make sure that the particles are properly dissolved so that we can stir it properly, stir it very well. Sometimes you need room or space to be able to stir the solution properly. Alright, we're going to add the SLS solution to the already prepared soap solution now. Just like I said earlier, you can use Texapon or SLS, but here we're not using Texapon, we are using SLS. The next salt we are dissolving in water now is STPP, sodium tripolyphosphate. This chemical looks so much like common salt, what we generally call table salt. It's very easy to dissolve because it looks so much like table salt. So now we are going to add it to the solution and stir it properly. So I think that's all for the solid materials. We've all dissolved all the solid materials. We only have the liquid material left. No, we have color left. Color is still left. We're going to dissolve it in water also. Make sure you take time to stir it properly. Now we are going to add sulfonic, a very thick, dark chemical, having honey-like appearance. Just like I said earlier, sulfonic is not the same thing as sulfuric acid. They are two different substances. Alright, now we are adding foaming booster, transparent liquid, stir the mixture properly. Alright, now we're going to add, this is Texapon, but we're not using it, so keep it aside. Now we're going to add color to it. First of all, dissolve your color in water, just like other solid materials. The generic color most of the time people use is green, and green has this appealing color for soap. You can use orange, whichever color you want, but most of the time people use green because green has this generic appearance and appealing for soap. Rinse it with water to make sure everything goes down. So just like I said earlier, the total volume of material we're producing here, of soap we're producing here, is 20 liters. So the volume of water you're going to use should be about 20 liters. This is perfume. Just like I said earlier, we have different kind of perfumes in the market. You can make your choice. Perfume will give your soap a very good fragrance. So our homemade soap is almost ready, as you can see. Just continue to stir it. So what we need to do now is that we have to top up the water to the level, because it's very thick, it's still very thick. You can top it up with water to get to the 20 liter mark. So just top it up with water. So this is all you have to do to make your soap. Very, very easy. It's a lot of fun and very, very interesting. So thank you very much for watching. If you like this video, give us a thumbs up and subscribe to our YouTube channel. Now, if you allow the soap to stand for about 20 or 25 minutes, the green color will show up very well. So as we proceed, you will see it. You can see how thick the material is. Very, very thick. You can still add water to neutralize it a bit. This is how the soap looks like if you allow it to stand for about 20 to 30 minutes. The green color is fully out and more appealing.